Hi, friends. Mr. Murphy here, talking about layers of the atmosphere. Here's what you have right now. You have your note sheet. You received it from me. You are watching this video. You can stop, pause, rewind. Don't fast forward. Please watch. I'll be succinct. There's your word of the day. Sometimes it's cool. I have the ability to annotate this slideshow, and I'll perhaps add some annotations. So please follow along. We're talking about layers of the atmosphere. Let's go. All right, well, first off, what is the atmosphere? I mean, it's pretty simple. It's a thin layer of gas that surrounds Earth. It's actually held together by gravitational pull. We had to think about this yesterday. We are talking about invisible things, but invisible things still are matter. They have mass, they have volume, they can be held by gravitational pull. They extend, this atmosphere extends from the surface all the way to outer space, and it contains obviously gases. It contains some liquids and some solids. Why is it important? Well, it protects us. Okay, it is our protective barrier. Without the atmosphere, we are not around. Venus has an atmosphere. Mars has an atmosphere. Two planets close to us, similar in size. Their atmospheres are different than ours. Life cannot exist. Ours balances temperature on Earth. We have weather because of it. Okay, it protects us from dangerous rays from the sun, and it supports our planet and supports our biosphere. So we know our atmosphere is gas, but what makes it up? Most common thought when talking about what the atmosphere is made up of, we think most of the air in this room, take a deep breath, is oxygen. It's actually nitrogen. Nitrogen is the most abundant gas, or most commonly found gas in our atmosphere. Makes about 78%. Next is that oxygen that our cells need. And then we have our other gases. Trace amounts, argon, carbon dioxide, which we'll talk a lot about, methane, maybe it's water vapor, maybe it's a little bit of helium, but these little minimal amounts. Carbon dioxide, we can increase the amount of CO2 in our atmosphere by human activity, which we'll talk about later, but nitrogen and oxygen are two most abundant gases in our atmosphere, which you just read about. So it's weird to think about, like there's solids in the atmosphere. Well, yeah, and if you notice, if you look in your notes, I actually mixed those two up, but deal with it. Here's how you know there's solids in the atmosphere. Raise your hand if you have allergies. I have allergies. You're probably allergic to some of those solids. So most commonly we have dust, we have salt, and then we have things like pollen, ragweed, things that I'm allergic to. But those things are all part of our atmosphere. Then we have our liquids in our atmosphere. Most commonly, we have water vapor. So up to about 4% sometimes of our atmosphere can be filled with water vapor. Look up in the sky if you can see it. Come on, look. I see some clouds right now. There is a little bit of water vapor up there. And then we have stuff like sulfuric acid, which comes from the earth and erupting volcanoes, and which can have a significant impact on our climate. So let's talk about it. Okay, what is it? Earth's atmosphere. It's important. It's made up of mostly nitrogen and oxygen. It supports life. Okay, blah, 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 blah. I get it. Well, what is it made up of? It's made up of 5 layers. We introduced those 5 layers yesterday. Thought to think about is which layer is the most dense. Well, more dense things sink, so the layer that we live in is going to be the most dense. And we separate it by our upper and lower. Good little picture. We live in the troposphere, the most dense layer. As we go up, we have tropo, we have strato, we have meso, we have thermo, and we have exospheres. I remember it by, and it sounds silly. Taylor Swift makes tasty eggs. You'll never forget, I promise. So let's start in the lower atmosphere. It contains most of the air. It's where we live. 99% of all water exists in the lower atmosphere. We need water to live. That's why we're down here. So let's start in our troposphere. It's where we live. It's closest to Earth. It contains 99% of that water vapor, as I just mentioned. 80% of the total amount of gas in our atmosphere. And it's actually heated from the ground up. So temperature is going to get colder with altitude. Underline that word altitude. That's going to be an important word for us during this unit. And if we were going to draw like the density of the troposphere, so imagine like this would be a cross section of all the air in it. This is a very, very, very dense atmosphere. If these are gas particles, there's molecules all packed together. We can take a big old deep breath of the troposphere. Do it again. If we were in the exosphere, we would not be having that luxury. The troposphere is going to contain weather, it's going to contain our pollution, and it contains this fancy thing known as the jet stream, which we will talk about later in this unit. Well, let's go to layer number 2. Second most layer, therefore it's the second most dense, starting with the tropo, then we're into the strato. It contains 19% of all of the atmospheric gases in this layer. We have a temperature that increases as altitude increases. There's that word altitude again. You'll hear that a lot with this unit. And you've probably been to the stratosphere if you've been on a jet plane. The stratosphere is really high. So nothing really is going to live there. You're only going to fly there in your airplane. What makes the stratosphere so significant? It contains the ozone layer. You've probably heard of the ozone layer before. It is this very special layer of gas, invisible gas, that protects us from the sun. It's the reason why the stratosphere is warm, because that gas essentially absorbs those harmful rays. It is made up of 3 molecules of oxygen. It's that simple. If this was be a molecule of oxygen and those sticks represent bonds, O3 is our friend. And this little picture just kind of shows you. You've heard of ultraviolet rays. This ozone protects us from those ultraviolet rays. Let's keep going higher and higher and higher. We're now to the upper atmosphere. Unless we go to space, we're probably never going to be here, FYI. I would love to go there, but I'm probably never going to be in the upper atmosphere. The third layer is the mesosphere. It's the coldest layer. Temperature decreases as we increase in altitude. So we're noticing troposphere, as we go up, it decreases. In the stratosphere, it starts to increase. In the mesosphere, it then starts to decrease again. We'll talk about that, why that is. And like this would be like shooting stars or meteors. If you've ever seen them, they tend to burn up in the mesosphere. We're getting close to outer space. We are in the thermosphere. It is the 4th layer. It is the thickest layer. It extends 85 to 500 kilometers. That's like, I don't know, 50 to 270-ish miles. You could probably check my math on that if you'd like. There's a very small amount of gas. So if I was going to draw this density circle, in the troposphere it was really dense. In the thermosphere we're like, yeah, there's not a lot of stuff packed into that area. It is the hottest layer. So think thermal energy, thermo meaning hot. It is going to be our warmest layer of the atmosphere. And it's going to contain this really cool thing called the ionosphere. That's like if you've ever seen the Northern Lights or the Aurora Borealis, you may have seen the ionosphere. And this is kind of where like the International Space Station, we're in outer space now. There's going to be some satellites in the thermosphere. And we are at the last layer, the 5th layer, the uppermost layer. There's virtually no gas. You might have a space shuttle there if you were going to be in outer orbit, but there's not much going on in the exosphere. If we were going to draw this density circle, it might look like that. Nothing can breathe, not enough gas for anything life to be supported. So we do have these like transitional layers. I wanted to mention this. You might see it if you're looking at a picture of the layers of the atmosphere. So we have like these pauses, which just means transitions, because it's not like you're running into the troposphere and then boom, all of a sudden you're in the stratosphere. It kind of gradually spreads out there. So we have like tropopause, stratopause, mesopause. I just wanted to mention that. Don't worry about memorizing that or anything like that. And I like this picture. It shows you the layers. It kind of shows you where these things exist on the layers of the atmosphere. We're going to create a poster here very similar to this, which we'll introduce in class here shortly. But I just kind of wanted to show you this good visual. And then the next two slides look like this. Please double check your notes with my answer key that I've posted here. Pause this, make sure you have everything filled in. You will notice on this slide I have a couple annotations, and remember, I know it sounds insane, but Taylor Swift makes tasty eggs. That's how you can remember the layers of the atmosphere. Thank you for watching. Thank you, atmosphere. Have a great day.